Good morning, everyone. Welcome to the 2019 AWS Public Sector Summit in Washington, D.C. My name is Shalisa Chambliss, and I will be your room host today. I just wanted to take care of a few housekeeping items before we get started. Please make sure that you download the AWS America's Events app. It is available in the Apple App Store, or if you are using an Android device, you can download it from the web. Additionally, there is a QR code reader just out these doors and to the left to assist you. You can use the app to build your schedule and also complete the surveys after your session, engage with the event. I'd like at this time to please ask if you silence all of your devices. These sessions are being recorded and the recordings will be available after the event. Make sure that you complete your surveys in the app after each event so we can gather your feedback and make improvements down the road. And at this time, we'd like you to please welcome to the stage Professor Chen from Arizona State University, Computer Science and Engineering, and Doug Fulop, AWS Senior Project Manager. They'll be talking on developing and teaching robotics with AWS RoboMaker.
Good morning. Thank you so much for coming in this morning to chat about robotics. First, I'm Doug, a Senior Product Manager at AWS as part of a new robotics and autonomous services group. And so we're focused on making the lives of robotics developers easier, especially with our first product, AWS RoboMaker. Afterwards, Professor Chen will talk through teaching robotics at Arizona State University. So when we talk about robotics today, their growing intelligence capabilities are greatly expanding. There's a lot more robots today than there were in previous years, and we'll talk through some of the numbers of the staggering growth there. And then we'll talk through how you can develop your own robots with AWS RoboMaker, and then how to teach robotics as well. And so we'll talk through a variety of public sector examples as well as robots in the wild. So when we think through robots today, we often think through the robots that have descended from science fiction. The robots that are manning the International Space Station, that are exploring Mars, and our new product, AWS RoboMaker, is used by those teams as well. However, in 2019, robots are assisting us in a variety of ways closer to home. For example, we have an elderly care walker that will find you in your apartment and take you on a safe path to the bathroom late at night. We have robots in Amazon warehouses that are helping to deliver products to customers the same day or next day. So it's over 200,000 of those robots in Amazon fulfillment centers. We also have drones, underwater vehicles that are performing day-to-day inspections of critical infrastructure, as well as new development kits that can help teach kids science, technology, education, and math, engineering and math. In 2019, we roughly have about 350,000 mobile material handling robots deployed by the latest industry reports. And then by 2030, it's estimated that 70% of all the mobile material handling equipment, such as forklifts, will be automated. But that's just the very start of where robotics are being used today. We have robots in every industry: construction, retail, that are introducing store guests to the latest products, hospitality, where where customers are being met either at a store or at a hotel and being greeted by their name and shown to their room, all by a robot, or a robot delivers your room service. Healthcare robots that are helping nurses deliver care, as well as robots that are helping to grow our food. At the basic level, a robot is a platform that allows for the collection of sensor data, the computing and decision-making to figure out what it should do next, creating a plan of action, and then a set of capabilities to act, whether it is to move around, to take a product from point A to point B, or to help with a dexterous manipulation task, such as assembling a small product. Many of our consumer products are made with the assistance of robot arms, for example. So in order to help make it easier to develop robots, we launched AWS RoboMaker last year, a service that makes it easy to develop, test, and deploy robotic applications. Additionally, we make it easy to bring in AWS services to make these robots intelligent so they can understand their environment, understand who they're interacting with, and make the appropriate decisions. As part of robotics development, you'll see that it looks similar to a software development pipeline. A lot of iterations, a lot of testing, deployment to the field, and then often the realization that you need to add more features in order to deliver on the real-world capability you sought to offer. So at first, we define the product. We make sure, is a robot the best solution for this problem? We'll select the software and hardware, including software frameworks. How are we going to get to market as fast as possible using what's available? Then develop your robot application, test it, simulate the customer environment is one of the unique areas here where, for example, you can have a virtual environment of your customer, say, store or customer hotel, and simulate your robot going through that environment so you can make sure that your application is set up properly. Lastly, you can develop and deploy and manage this application and tell robots to perform tasks or receive data from them to figure out what you need to iterate on for the next release. Our platform is built on top of Robot Operating System, which is the most widely used open source robotics framework. It consists of two primary components, ROS, Robot Operating System, and Gazebo, which is a 3D simulator that we'll talk more about. There are about 16 million downloads of ROS in 2018, which is 4 times what it was back in 2014, and it's been the most widely used platform amongst our commercial customers as well, in addition to education users. So AWS RoboMaker has 4 components. There's a set of cloud extensions for this robot operating system that let you bring in the latest AWS services to make your robots intelligent, a development environment that lets you edit robot code without setting up any local software development environment. We have simulation, these simulated worlds that you can either bring to AWS RoboMaker or use pre-built ones, and fleet management, so you can manage the fleet of robots. Across these 4 components, there are a variety of aspects that really deliver a lot of value to robot developers, and we'll talk through each of these categories. For example, we have cloud extensions that allow your robot to understand language, speak, process video streams, recognize objects and scenes in images and videos, and then log and monitor data so you can understand what your robot is doing out in the field or collect more data for further analysis. We have a development environment that you can open and launch with one click and use all the latest ROS tools within your development environment. We have a simulation platform that lets you use these 3D worlds of customer environments with a zero infrastructure to provision. And so as you want to scale up your testing and test hundreds or thousands of robots, you can have AWS RoboMaker launch each of those customer environments, test your code for you, and parallelize that testing. For fleet management, we integrate with AWS IoT Greengrass, which gives you the latest in security, deployment, robot registries, and other tools that simplify this undifferentiated heavy lifting of making sure that your robot has the latest application running on it. Then, to make it really easy for customers to use our services, we built a series of sample applications. These sample applications can be launched with a single click and allow you to see a robot in a 3D environment performing these tasks, and you can use the sample code here to launch your own customization, as we'll see some of our customers have already done. So overall, we allow you to get to market faster using intelligence from AWS RoboMaker cloud extensions, the zero infrastructure provisioning, which saves you time of managing your own fleet of servers and configuration, as well as a life cycle of being able to update, deploy new code updates, and retrieve data from the field to understand how your robots are performing. So we have a variety of great customers. I'll show a few variety of customers, and then we'll discuss how this applies directly to the public sector. But today, we have one company, Robot Care Systems, which makes a walker for the elderly, which helps keep them safe. And we'll hear a short video from their founder created just for this talk.
I build robots so that elderly people can live richer and safer lives with the help of technical solutions. Leia is a care robot, but also a tool that helps people walk and ensures that they live safer and richer lives. Our users are Parkinson patients and seniors who have trouble walking. Leia is equipped with numerous sensors, and it measures a lot of parameters and uses them to adjust the movement to the disease and the disease profile of the patient. When I know how to use her walks, I can make sure that the Leia stops in time. The use of electrical motors will make sure that Leia can stop properly. While walking, we can determine people's optimal walking movement, the best way to provide their stability, and we can correct their posture. We can help to detect the obstacles that are in the way and ensure that they walk safely. We can improve people's daily activities, help them to go to the bathroom, to cook, to walk safely, and to exercise more. As a result, your body is stronger and you can do a lot more. Leia isn't just for seniors and patients, but it's also for healthcare institutions. We have a shortage of care professionals, and Leia can provide assistance. It can give insights into the patient's health and movement, and ensure how to adjust their therapy. When I see how happy the users are, and that they can go outside again and enjoy life, because of something that I made, it fills me with pride.
So in a very different industry, Stanley Black & Decker shows us that we can use AWS RoboMaker to perform daily inspections of customer sites, such as construction sites, create models that are browsable through AWS RoboMaker, and then create new services such as robots that can perform the daily inspection of construction sites, report back their status, and allow for the latest, say, computer vision, analytics processes to determine if the building is being built properly. Additionally, we have customers such as Future Robot, which is creating these concierge robots that can introduce customers to your store, walk customers to the correct courtroom as one project that they have that's active, and use AWS services to allow these robots to speak, understand their environments, understand their customer needs. Across the public sector, when we talk about robotic process, we talk about robots, we often talk about robotic process automation, and so automating the paper or electronic forms that we have. And one of the first examples that I saw, which kind of tied this all together to say some common public sector uses, is when Future Robot is able to take in some, say, paper forms or kind of more traditional processes and automate those, such as escorting people to the correct room, or helping carry these products say, forms to where they need to go as part of a scanning process. And so that's one example of public sector. I know that robotic process automation is in its early days and growing rapidly. We think that robotics, and especially physical robots, are going to add a lot of capabilities to that process. So as part of building a robotics development platform, we hear a lot about the needs to teach robotics or to use a robotics platform to help students engage with science, technology, engineering, and math. And so we've created a great set of partnerships with educators across a variety of institutions that are actively using AWS RoboMaker in their curriculum. One that we'll talk through today is Arizona State University. And so Professor Chen will come up on stage and share more about how he's teaching robotics using AWS services.
So, good morning. I'm so glad to be here and to share what we have in teaching the robotics and particularly working with AWS. And we have actually, in ASU Computer Science, we have a very strong robotic program. We have a dozen professors actually working in robotics. We just announced probably a month ago, we started a master's degree in robotics. So I'm just representing myself to talking about my project. As I said, I'm not talking about the entire ASU robotics. We have a huge program there. So I want to share a few projects, what I have been working on, and particularly working with Amazon to really get the AWS services and the RoboMaker deep readers into our curriculum. I'm going to start with the robotic guide dog project we just finished, and also we will be talking about using Amazon Alexa in our project to also inside the robotic guide project, the vision impaired person will be talking with the robots through the Alexa, and I will be also talking about the race car and the drone project that we have been using. Okay, first let me show you a video on our guide dog project.
Could this Robotic Rover eventually replace seeing eye dogs? ASU students developed it and impressed judges in Shanghai.
So this is a guide dog and the blind person in a wheelchair. So, yeah, they have the traffic light. Okay, the sound is not coming, but this guide dog will be able to recognize the traffic lights, will be recognize obstacle, and so that a blind person can walk through the traffic safer than just with we try to make it more basically safer than a real guide dog, which you can see, they cannot see really the color for the dogs and so on. So this is where we have a wireless camera installed on the dog, and yeah, we also have other forms of the same robot. Yeah, this is what we actually just participated in the Intercom competition in Shanghai back in July last year, and we got the first prize for this student project. So you can see this project is, what we have is, we use, because of the Intercom, we use Intel's upscale board as the main computing platform. We have a Wi-Fi camera, we have the dog. This is really a mechanical dog that carries the camera, and then we basically send back the instruction to the dog based on all the camera and other sensors, so that the dog will be know what the intention is. We also have the Amazon's Alexa is connected, and so the blind person is sitting on this robot chairs. So the main thing is we have some, we call the edge computing based on here, but all the color and the image processing, the traffic science, we utilize Amazon's cloud, where we have, you can see, we have the data coming, and we start an instance. We use Jupyter as our programming environment. We use TensorFlow to train our models. We use Python to do the processing, and here we use E2 Cloud to store those data. So this is our framework, and for processing the guide dog project. So here is a part of the Alexa, which
Alexa, ask the robot how it's doing.
The
so
robot
here,
is
yeah,
sleeping.
that's where
Would
we
you like me to
communicate.
wake him up?
Yes. Alexa, tell the robot there is an ASU football game soon.
Go Devils, go.
Alexa, tell the robot that we scored a touchdown.
So that's the devil is going to do push-up every time we get the touchdown.
Alexa,
So,
tell the robot that ASU won.
He cannot contain his excitement.
okay, so the action and the audio is a little bit off synchronization here. Yeah, that's where the part we have the same kit. We can build a dog or we build a person. So the software is the same, just the hardware is different. So that's the part of the voice, Alexa voice controlled robot. So now let's come to the main part I want to share. That's we start to utilize the RoboMaker simulation environment and also the deep racer hardware. We just got, oh, sorry, yeah, go back. We just got the hardware now, and but we have been mostly doing the simulation on the deep racer. What we have been doing with all my students have been doing is, yes, we are going to tune the car to race through the track with better, yeah, we're developing those rewards functions and the hyperparameters tuning so that we can get the robot race through the track. Okay, so this part is the main part we have been working on. How can we improve the performance of the deep racer in the simulation environment inside Amazon Cloud? So we started with a very basic one, okay? So just get it running. So that's where we will learn what's going on. So the basic race is we just have building an absolutely simple function to make the robot move through the track. So what we do, you can say if you are learning driving the first time and in a big space, right? What we do is we just put the acceleration, the gas pedal, constantly, very slowly driving the car. So we put 0.5 and the brake, we don't brake if we drive very slow. That is the race track, right? Just drive so that everyone can get started. So the gear, what do? We don't switch, we just put on 2. I can drive slow and I'm not driving very fast. Okay, and so that's what we need to do a little bit is about the steering, right? Yes, even you're driving the first time, you still need to be able to steer. So what we put a simple function is, okay, yes, this deep laser has this laser, okay, 360-degree sensor, so that I will be able to see the edge of the racetrack. What this basic function does is, stay in the middle. Okay, look at the angle and look at the track position. And so this simple function say, we try to stay in the middle. That's it. That is one we will be able to make through the deep maker, the deep racer. Okay, so that's where, because this section is about deep research. So that's what I want to share everyone. If we want to start, we start with a very basic function. Now, but obviously that's not going to make you win the race if you are just driving that way. Okay, so that's where my students have been defining those advanced driving functions and also tuning the hyperparameters. So we are developing very complex reward functions. For example, now the acceleration is not going to be constant, right? Just like we drive a race car. So we will speed up to the maximum if we say straight, right? And so that's where we are going to develop a separate function for the acceleration based on the angle and the track position surrounding the car. And yes, again, if we are accelerating, we cannot set brake to 0. You're going to crash, and when it's turned too fast. So therefore, we're going to define the brake function. Okay, we're going to look at the angle and we are looking at the track position, the 360-degree track position. We are going to do the brake. Okay, and the gear part again. So that's why actually is relatively simple. We just define the function based on the current speed, just like we drive a stick car. We start with gear 1, right? Once we get 20 miles above, we shift to 2, and then shift 3, shift 4, shift 5. So this one we have to basically change the gear just based on the speed. So we also built on advanced function the ABS and the traction control. Okay, so you can see those are the modern cars. You actually have to detect your body speed of the car and the wheel speed. So these two speeds must match if you drive properly. But if they mismatch, okay, so basically like you're sliding, you brake too hard, your wheel is absolutely blocked, but your car is moving, and so in that case, the computer, the ABS will take over the function. So that's the part we make sure that we can, in that way, we can drive through at the maximum speed. And also the traction control part, again, is when we are in the curve, okay? Our speed is too fast. So if you have a traction control, or the most cars today have the traction control, they will actually slow down automatically even you do not brake. So that's where we build the traction control part. So right now we're using the same steering functions to keep in the middle, because right now we are developing the one-car race, okay? And we also are writing more advanced function to passing a car. Yes, if you get multiple cars, or you have to pass in the car, then you have to detect the car's position, and then you cannot drive in the middle to pass the car. You have to drive around. So there are many more functions we are developing. We're also developing following a car in the safe drive mode. So if there is accidents, your car, you cannot pass any other cars. You have to just follow the car you have. So this is what we have been doing, and the students get really very excited. Okay, so we started with a very simple function. We could even get those. Yeah, I'm teaching robotic camp for the high school students. I can even get the high school students to work on this part. I just need to explain. Okay, so you start from here, right? And then you start to do a little bit more and more to try to improve your autonomous driving, and so that the goal is to get the speed. Okay, like my first basic one, we start go through the track in about 1 minute 14 seconds if we just do this one. Okay. Then with this one, the students will be able to improve. Right now, I get 54 seconds. So then I challenge students now, okay, go ahead to improve the tuning those parameters and or even bring new functions so that you will be able to get those your autonomous driving much faster. So that was the learning part. Okay, you can see we can actually start to teach the students what autonomous driving means and what all those parameters you can actually impact the driving, and also you can write new functions. So that's the part. If we break down our big autonomous driving program into small pieces, get students to improve one thing at a time. That's how we teach students in our undergraduate program. Yeah, this is the part is our FS100 is our first class when students enter into computer science. We teach Java, but many of you, if you are in the teaching, you know it's very tough for students enter to learn Java. There are a lot of concepts they don't understand. So that's where we start to bring the robotic program into it so that they were they learn if then else, they learn switch, they learn loop, all those things. But now they will see, okay, what you modify and how your car will react and so on. So this is a part of what we were doing in different platforms. Now we switched to the AWS RoboMaker. So this is a better environment, obviously with the support from Amazon, with ROS, with Gizbos. That's what we are very excited. We get a new platform to do what we have been doing. And so the next one is similar. So this is our students, or my students' project. We are doing the machine learning. You can say this drone, we are remote control the drone to fly, okay? And so you can say they get different positions. They can go forwards, backwards, left, right, and neutral, okay? So what we try to do is we are going to labeling the flight data with the remote control. So what button they get a hard landing in this video, but we do improve to have a soft landing. Okay, here what we try to do with this is you can see when we remote control the drone. Oh, sorry, this button. Okay, and this flight sensor. They track 6 different parameters of the robot position. And so we get those data. We record this flight data. So, and then we are labeling this data through the remote control buttons. When you control forwards, then we will be matching with this particular piece of data. When you do the down, when you do the left, right, and neutral, so we will be able to automatically label those data with the control. This is our first step. Okay, we're doing the labeling. So then we will be using then we go to the Amazon, and we do the feature extraction of this data. This data is too time-consuming and to compile. So we're going to do the feature extraction of this data, and we have a Python program to do that, and then we will be using TensorFlow to train the model. How this actually data fit into a particular machine learning model. And then, so this is training stage. We're training the robot. So now the second stage is the recognition. So now we fully trained our data. So now we let the drone go and fly without control. Then we collect the data, right? We collect the data. So let's just imagine Amazon start to use drone to deliver the package. Okay, so then the customer says, I never received the package. So then what we do, we can now start to look at the flight data. Okay, so then use this flight data, we are going to compare with our training data, okay, to figure out where actually and how the drone actually flew and where it actually went. So, right, so that's the second, the recognition stage. We have a training stage and recognition stage. So basically, we put the same data, and then we do the same feature extraction. We use a TensorFlow to get the models, and then we will figure out how this flight actually, or the drone, where the drone went. So again, we are not doing the commercial system. We are teaching. We are teaching students how to do machine learning, how we use Amazon's environment to get, we control the data. We basically send data into Amazon. Then we do all the whole analysis into the Amazon cloud, and to get those training and the recognition. The purpose is for our teaching. We need to teach what's the machine learning, what is artificial intelligence, and how to do data processing. So this is the whole circle. Students go through this lab. So they will have very good idea, okay, what machine learning training and recognition means. So, all right, so the next step, and many of things, yes, from the Amazon is very new. We have been starting to use, and this is what we planning, the course I've been teaching. So one of the courses I'm teaching is called CSE 445, which is service-oriented computing. I have been teaching this class, or I established this class in 2006, and I have been teaching for 1,000 years. And we have been started with our own server, then we have our ASU cloud server. So now we really want to move this into Amazon server. Amazon, we are based on the Windows server, but Amazon also supports the Windows server. I started created the Windows server. The main thing is a lot for myself. I get 150 students in the class, okay? So the students were writing the services, writing web applications. We also use AWS commercial e-commerce services. So the main thing is we need to create a server for each student so that they can mess around to do their assignment. We can assess each student what they do. So that's the one I'm in the process to create those service-oriented computing class with each student server. And so this is the class. And also, as I mentioned, the AWS RoboMaker, we have been teaching those autonomous driving, and in our FS 100, this is our first engineering class. We are not using the Amazon RoboMaker yet, but I started to look at everything that works. Yeah, from my side, I just need to allow how can I push this to several hundred. We have in our computer science, we have 850 students in this fall semester coming to take this class. So obviously, the challenge is how we get those large classes using the RoboMakers. And so we have a lot of things to do, and so I look forward to get more support from AWS, and we can put more of our courses into the Amazon, right? So now we can take questions together, right?
Any questions? Yes.
From AWS, and I work with universities in Latin America.
Great.
I wonder if you could talk about. Hey there, I'm Hillary from AWS. I work with universities in Latin America, and I wonder if you could talk about sort of some of the prerequisite coursework that your students get to the point where they can be in the advanced course and doing this. I understand you're working on a seminar for first-year students, but what does it look like as you think about the curriculum development over time of what are the foundation building blocks to get to the advanced stuff?
Yes, absolutely. For our FSU 100 class, that is our first class for the high school student entering the university. There is no prerequisites of any kind. Yes, as we move to like the 445, that's the senior, or we get the junior senior level students taking that class. That one means the students already have really advanced programming experience through 3 years study. Then here we try to do is to create the web applications, like how we create our own e-commerce website to sell books among the students, sell the user books and so on. So in that case, they don't really need the specific prerequisites. They do need the programming experience to get into our 400 level courses. But this will be the first time in our curriculum to really teach how to fully install and using a server and configure the server to get all the ports opened and to convert a file into applications so that they will be running as a services and so on. So yeah, that's just the general prerequisite of programming, object-oriented programming, but in that particular course, no specific requirement for taking that class.
Additionally, we're also hard at work creating a bunch of education curriculum around the RoboMaker and getting started with the prerequisites with AWS in order to be able to use a service such as RoboMaker. And so we've been hard at work on a badge curriculum for that prepares students. And then the sample applications are also easy to use as well to get a sense of the final application when it's running and start to dive in deeper, see how it's working, and figure out what else students, and students for themselves can figure out what they need to learn based on the kinds of end application they're trying to create. Yeah, do you mind using the microphone?
Julius Williams from GSA, federal government. Are you engaging right now with the government on RoboMaker by any chance? I know this is the public sector, but are you engaging with any government facility?
Agencies? There's a lot of customer inbounds that we've had from every customer segment, especially when we talk about categories such as in inspection or trying to automate some existing processes. So happy to continue the conversation.
Hi there. Thank you for your talk. I'm Kenneth Wong. I'm with Virginia Tech. This is kind of a question about the robot operating system and the implementation of it. Is there a way in the system where you can abstract robot movements so they're not specific to the type of robot you're talking about? So if you're talking about a car or a drone or a walker, you can just tell it move forward, and then there's some other layer that tells the actual part of the robot what to do?
Yeah, so I think the best example of that is if we go to the sample applications or some of the cloud extensions, we built in kind of out-of-the-box capabilities to be able to send, say, a voice command to say move forward and process that. And then, so for example, when you ask move forward, when you ask the robot to move forward, it'll ask you how far, which direction. It'll confirm, hey, there's a cliff. Are you sure you want me to run over the cliff? And so we have that level of abstraction built out in the sample application. It works on a ground-based mobile robot, and then you can adapt it to a drone as they have with move forward, left, right.
Right, just add on, we will use different platforms. Right now, basically, we are just transform. They are very similar functions. We just need to call the different functions. Our application logic will stay the same.
Thank you.
Mm-hmm. Any other questions? All right, well, thank you so much for coming this morning. I invite all of you to try out our service, and whether you're trying to teach with it or develop real-world robots with it, I'm happy to help. I would love your feedback, and hope to see some of your customer examples up here the next time around.
Thank you.